Hello everyone, how are you? In today's lecture, we will discuss about the Bernoulli's equation. And from the previous course of ordinary differential equations, we know the method of solving is. And now students, our target is to use the canonical variables and convert this Bernoulli equation into a separable equation that can be easily solvable. And one way of checking the invariance of a Bernoulli's equation is by using the least invariance condition, and that is given by this one, that is y of x plus y of y plus x of x into f minus x of y f square is equal to x fx plus y fy that I have already proved in my previous videos. Now students, the one way of finding the infinitesimals is by using the hit and trial rule. Like you can select the values of x and y and substitute in the least invariance condition, and you can check either your least invariance condition is satisfied or not. If your least invariance condition is satisfied, then we say that these are basically the values of infinitesimals x and y, and obviously when you know the values of x and y, you can find the corresponding Lie group. Now students, here, like I have select the value for x that is equal to 0 and the value of y that is equal to e raised to power n minus 1 integral p of x d of x into y raised to power n. Now students, if you use these values of x and y, and obviously your f of x y, the value of f is equal to q of x y raised to power n minus p of x y, because you know from the least invariance condition that we can write the value of f of xy is basically dy by dx. Okay, now when you substitute these two all of these values in the least invariance condition, then you will get equation number 2.58. okay, and when you use these values, you can verify that basically this equation is identically satisfied. Now students, to obtain the change of variables, we know the transformation that we have already derived, that r of x rx plus y ry that is equal to 0, and sx plus y sy that is equal to 1. But here student, the value of x is equal to 0, so we will only get the value of something like this, like x rx plus y ry is equal to 0. So if the value of x is equal to 0, then you will get y ry is equal to 0, and the value of y is given over here, so you can write e raised to power n minus 1 integral p of x d of x y raised to power n into ry that is equal to 0, and in the similar way you can write the value for s of y. Now student, there is no need to solve it further. You can just use this technique on your question, and you can easily find out the corresponding answer. For example, here we are given example, consider y prime plus y by x is equal to xy cube. Now you can see that this is the Bernoulli's equation, and here we can identify that our p of x is equal to 1 by x and the value of n is equal to 3. So we will write, like we want to find the value of capital Y, the infinitesimal, so that is equal to e raised to power n minus 1 integral p of x d of x y raised to power n, and if you substitute the value of n, then you will get this one. Okay, now our next target is to find the value of ry, to write this equation in terms of the canonical variables, and obviously from here you can write ry is equal to 0 and x square y cube sy is equal to 1, and by the method of characteristics you can find its solution. And our next target is to select the particular values for r and s. So I have written here r is equal to x and s is equal to 0, so we will get the values of r and s as given in this equation. Now obviously you want to convert the given ordinary differential equation, that is given Bernoulli equation, into a separable equation. So just substitute the values of y and x from here, and then you will get this equation, that is a separable equation. And you can also write it as ds is equal to minus 1 by 4r into dr, and you can easily solve it by using the method that we have learned in ordinary differential equations course. Now students, this is all about this lecture. Thank you so much.